In symmetry, we're learning about enlargement. Enlargement is making an object or a shape bigger. Here I have a square. If I was to make this square bigger, I would need to decide how big I was going to make it. Presently, it's on a scale of 1 to 1. If I have a look at my scale, 1 means the size I have is times 1. If I was to double the size, I would need to make it 2 times its size. That is quite easy. I have a look at my base. I have 1 square. I need to make that 2 squares big. I look at my height. I need to make that 2 square big. And suddenly, my 1 square has grown to that size. That is a scale of 1 to 2. If I was to have a look at my little square and say I want it at a scale of 1 to 3. 1 is my original size, 3 means 3 times bigger. I look at my base, I need to make my base 3 times bigger. I need to make my height 3 times bigger, and suddenly my enlarged square looks like that. If I was to have a look at enlarging on a Cartesian plane, remember my Cartesian plane has a y-axis and an x-axis. I need to take into account how far from the origin is my shape. I can see that my shape is 1 square away. If I was going to do this on a scale of 1 to 2, I would need to double the distance that my square started away from the origin. So I have a look. I've got 1 square away. I would need to make that 2 squares away. So on my x-axis, I'm now falling there. My y-axis, I've got 1 square away to get to my shape. I would need to move my shape up so that it was 2 squares away. Now my shape would be fitting there. I have enlarged my small square to double its size, but I've taken into account the distance away from the origin.